Hello everyone, welcome back to my channel. If you have wondered how privacy works on blockchain or how zero knowledge proof lets you prove that something is true without revealing the secret, you are the right place. In my last video, we already talked about ZK proof, how that work, why this, how that use and all of that. And today we are building one project related ZK sync, but from scratch. So we are going to use today the Circum. This is the most popular language to writing a ZK circuits, and SnarkJS, the Swiss Army knife for generating verify proofs. In this video, we are doing write a circuit with a Circum, generate a proof with SnarkJS, and verify it on chain that proof is working or not like that. So first is the key concept, the prover. Prover is the Bob, and what is job? Knows the secret and creates the proof. Bob knows the secret, and Bob have to create a proof. Verifier is the Alice, and check proof and learns nothing. Alice check proofs, but she don't know anything. Witnesses, secret data, Bob's private input. Whatever the Bob's private input, that is the secret data for this, and that is the witness. Circuit in this whole video or in this project, circuit what the circuit do? A circuit is the math logic things do and rules to follow. They give a plus, multiplication, different kind of logic to prove that the data is okay or not. And proof is like pi, cryptographic evidence. Now in this example, Bob says, I know two numbers. There is a sum is 15 and the product is 56. Product means we can say the multiplication. He proved it without saying the number. The number is 7 and 8. If the number is 7 and 8, okay, then 7 and 8 plus is 15 and 7 multiplied by 8 is 56. But Alice never sees them. Alice never sees the number, but he knows that proof is 15 and 56. With that, she knows that Bob's know the number, but Alice don't know. In this project, our challenge is prove you know two secret numbers and A and B such that. Inside our video, we have to give a two number A and B. There are the different number, and we prove like that A plus B is equal to 15. That is a public, and A multiplication B is equal to 56. That is also public. Means that in this 15 and 56 is public, but A and B number, what are the number for the A and B that we are not reveal in the whole video. When we verify to the LS, we don't reveal the number of that, but never reveal A or B. We are building this with using Circom and SnarkJS. How the ZK sync work and all the things we are already discussed in our last video. So today we are starting with the project. So the folder structure of this project is like a ZK sum product, and inside that circuit folder, input folder, and output folder. We have make this three folder. But before we started, we have to know the what are the Circum and SnarkJS. Circum is the domain-specific language for the written arithmetic circuits. Think of it like Verilog for the cryptography. You define logic gates using simple math, and it compiles into something called R1CS. R1CS, the full name is Rank 1 Constraint System. Like in this, we what do the by Circum? Circum is doing the simple math thing, the plus, multiplication, and the different type of math solution like that. R1CS is a universal format that ZK proof system understand, and R1CS with making with the Circum. SnarkJS is the proof of engine. Here the work of the SnarkJS. The SnarkJS is the proof of engine. It takes to compile circuit, runs a trusted setup, generate a proof, verify them, and even split our Solidity code so Ethereum can verify your proof of chain. Together, they are a gold standard for building a ZK Snark. What we do today, the private knowledge means these are the private thing. We don't want to show these numbers. Okay, the private number is A is equal to 3 and B is equal to 11. And the zero knowledge proof how we can prove that number we know by the proof of A multiplied by B is equal to C without revealing A or B. We give the C number. Public result, we give the public result, not the private input or a private knowledge. The diagram says the key component of the private multiplier protocol. That's a private multiplier protocol. Inside this, like, we only shows that the multiplier, but in our project we do the multiplication and the addition also, both are there. The left side shows the private rules a is 3, b 11, known only by the prover. The right side shows the public result. It's a c is equal to that can be that can be c by everyone, and everyone can verify this number. The middle section represents the zero knowledge proof process. This is the process which demonstrate a multiplied by b is equal to c without ever revealing the individual values of a and b. We are not revealing the value of a and b. We are only revealing the value of c, and that can be c by the any prover or any verifier. So after we start our project, before the project we have to install some dependency and install some Circom and SnarkJS if you don't have in your PC. So I give the line by line all the commands, and you can do with me, or if you have then you skip that also. First is install Rust, because the Circom language is made on Rust language. So if we want to Circum use, then we also have in our PC the Rust. If the Rust is not in our PC, then we also can't use the Circum. So first, the Circum compiler is written in Rust. So we install first Rust. So the first command to install Rust is this. Like, you can find it in Rust language document. First is like this command. We already we give this command. You have to write this command in your bash or in here also. I have already Rust in my PC. Okay, after the Rust install, we have to check the version of Rust. So we have to like this. If that version is not coming, then there is some problem of the Rust installation. So you have to do it proper. And if it is print, then the Rust installed properly. After this, you have to be install the Node.js and the npm both in your PC. So if you have already installed, then you can check with the node hash v means version. So we can see the version. So after that, npm dash v, then npm also version, because both are installed in my PC. You have to install Circum. Circum also in my PC, but I give you a command like a Circum installation command is this. You can see the package is installed, but also we verify the Circum is installed or not with the version number. If the version coming, your Circum is installed properly. If the version is not coming, your Circum is not installed properly. Like here, the all command we run now. Like first is the for installing Rust, then the version, check the version, then node and npm. If you are not installed, then you can install by these two commands. This command for the Mac, this command used for Linux, and you can check their version. Then after we install Circum and Circum version, my Circum is okay and the version is showing. So my Circum installation is not any problem. If you have any problem, if you get a command not found like that kind of problem, then you have to npm global bin to your path. You have to add this command. So here the all commands we can see also. After we install Circum, we have to install SnarkJS. SnarkJS command is this, like here. This command we have used here. npm install global. -g means global. Let's change 45 packages in 1 minute. Okay. Then we have to check the version. My version is showing, but there is another all options also showing. But it is okay. Then we made a one folder inside our directory. I make it already folder. You can make the ZK sync or ZK multiplier any name of folder. So here I already make a folder of ZK proof. Inside our folder, I already explained to you that three type of folder we made. The one is circuits. The second one is input. The third one is outputs. Inside this circuit folder, we create a new file, and the name of file is sum/product Circum. Okay, we made this file. Dot Circum is it shows the Circum. This is the Circum file. So inside this file, we have to first put a pragma Circum, like in the solidity file, in the sol file, we write here the pragma solidity. In the circum file, we have to write the pragma circum 2.0.0 or any latest version. After that, we have to write a template multiplier. Inside we do the private inputs. But here we write the private inputs. What are the private inputs? Our is like A and B. So here the signal input A and signal input B. And here we write the public output. And what is the public output? Signal output, public output. Public output, we say the signal output sum and the one other signal output product. These both are public output. Now we add the constraint. The first is sum. Here the sum, how we can do the sum? A plus B. The product. Product is like A multiply B. These both are our public output. And here the downside component main is equal to some product. We name here also some product. And you can see this kind of file structure and this kind of code in the Circum docs also, like we see now. Here the Circum docs, after the writing circuits, like this is the docs they provided. They provided only by the multiplier, but we also include the sum also. And here the output name C, and we gave the name of sum. So here we put a sum and A and B. So this is the simple file of circuit. They gave this like component main multiplier. So we do this also. We have to make here inside the input folder, we have to make a one input.json file. And here we put A is equal to 3 and B is equal to 4. Here we have to input this two product number. So 3 and 4 our number is. Then after we have to write one command to the compile this circum contract. Here is the circum. How you can write circum circuit. Inside the circuit folder we have a sum product.circum file slash dash dash r1cs. That I told you r1cs is the one of the most important, and dash dash wasm and sym and -o outputs. So all over that file compile and whatever we get inside the output folder. So we compile first and then explain after compile. That's, you can see that here you have a file of this some product has JS, some product r.r1.cs, some product.sym. Here you can like, then you can find it like something you don't see properly, that kind of things here. And here's the generate witness file, some product WASM. Here's the witness of calculator. They have do the many calculation with our like A and B. So we get this 3 file. After our file compiles, like here's the one command. You can know in detail, then you can search in docs also how that use, why this WASM code is multiplier 2.wasm. The other files needed to generate the witness. This file generate witness. This file a symbols file required for debugging or printing unconstrained system in annotated mode. And -o means the option. We use the option -o to specify directory where this file is created. We want that all file created in the output folder. So we use that -o to outputs. If you don't want to like give the specific directory, then you use only this and create that all compiles. After you can add the input.json file and inside the all two numbers, enter the directory multiply do and add multiplier to dot dash js, add the input in a file input.json and execute. Node generate before this, like so. With that output folder, the all files contains in this output folder. So here's the first files created. After we have to do the after the created, you also add here the input.json file. If you not added before, then you add now. After we use the SnarkJS to set up like powers to tau setup. So here's the SnarkJS power soft tau new bn 12812. The same commands you can see in here also. You can find it in here to be set up. After this all file, you have the circuit to ZK. Here's the file. Here's the command we have to first new powers to tau element. This we have to set up. So we here to set up this. So there is more file created. There's more one file created. Here's also the lengthy code, but we can't understand this. After we have to rerun the witness command. The node output some products. Let's output inside the some product.js folder and generate a witness. This output some product and some product inside this folder, this and the input.json and output.witness. We have to create this all file. We run this command and like the created this file witness.wtns, and here's also some code. After this we have to generate key and the proving key. We rerun this command. Okay, that command will be run. After this we run the SnarkJS powers of tau contribute to, and here's the name of the contribution. If you want to like give the name, then you give. Without that also it's working. It's entropy. You can enter any number, any words, like I put a and that's run and created the file of this one. Okay, you can see now. And after prepare phase 2, then we have to prepare phase 2. And if you don't run this phase 2, then also is okay. We create this phase 2 setup, and with this setup there is a created 3 files. These 3 files. It's taking some time. Okay, after we write this command and created this zk file, and here's also code. Now we have to export that file, and they detected the protocol and all of. We have to compute from our witness, compute the witness from input. Okay, this is created, and with this generate our proof, and with this command verify the proof. Like here's the OK command our working. So it means that our like verifier verify this our like input. Without they know A and B, we can verify this. So whenever it's successful, SnarkJS okay, then it's our proof is successfully, we can verify our things. So here's also like I explain you, like this is the phase 1. Power of tau. First we have to start the new power of tau ceremony. With this the power start, and we contribute the ceremony. So we use this command. Now we have to contribution of the power of tau in file. Like this power is start from only on your PC, because we are only the simple things doing. So this is this command for only about your PC. And then we can do this for the contribution, the first contribution or whatever name of contribution you have. Then here is a phase 2, but phase 2 we don't need it. If you don't do that phase 2, then also okay. Then after phase 2 we have to like start with the ZK file. So here's the ZK file command we already doing. And here's a phase 2. If you like use the phase 2, then use this command and the contributing phase 2 ceremony like this way, and export verification key. That's the entropies happen, but you can write anything, A, B, any kind of that. Then generate a proof. The proof generated by this, and with this proof.json and public.json, this all that contains proof. They have a two file made with this. The proof of JSON, like this kind of file, and the public JSON. Here's the answer, our the answer 7 and 12. Our input is 3, 4. 3 plus 4 is 7 and 3 4s are 12. So here's the both the answer is written in here. So these both file created with the generate proof and the verify our proof. After verify, it's okay, like okay mark is happen, then our contract is verified, and the verify from the smart contract. It's also possible to generate a Solidity verifier that allows verify proof on Ethereum blockchain. Like we need to generate the Solidity code, then we can use this also. And here's the all of the Circum documentation, and according to this documentation, we make the one proper contract how to prove the number without telling the number. So with this all thing, you can see the this kind of files. Okay, here's the whole file created by our commands. Line by line commands, we create the whole file. The first file is like some product r1.cs. With the first command, we can create this file, and what this contains system defining the circuit. With this file, the define circuit and the WASM. This file, WebAssembly used for witness generation. Then some product final ZKP. This file also the one of the important file. Final proving key for growth 16 proof generation. They are like it's a it's not a readable format, so we cannot understand what they are. Verification key.json. So here's the verification key, that kind of key that generated by the public public key used for verification proofs. This public key used for verification. Witness.wtns file. This file also created proof.json and public.json. Proof.json file is the ZK Snark proof. This file contains ZK Snark proof, and public is the public output of circuit file. Here's like many other files also created. They are these all files created by the phase 2. If you're not like using phase 2, then also it's okay for this. So now our like the code of this file is complete, and if you like get this kind of errors or anything, you can just only copy this error and like above error, and you put in the ChatGPT or anywhere, you can find a solution also easily. They give the proper command of you. If there any code and any file the missing, I make it readme file here and make all command line by line proper, so you can use that. So here's the simple our ZK proof with Circom and SnarkJS. So in the real world use is what where the use of the power of ZK sync and StarkNet. Real world uses of this ZK sync and ZK Stark and Circum. So the same flow powers like a ZK rollups, with the use of ZK rollups, like with the ZK sync and StarkNet, we can batch 1,000 of transaction in the one go. Then the privacy like a tornado case and S check, the hide sender and receiver both of the address. Then identity is a Sempore and the world ID like that. The prove edge 18 without our saying our date of birth. Then scalable voting, like a prove what without like revealing the choice, what who the person we have to do the vote, like don't reveal the choice and like prove the vote. That Circum is used by the 80% of ZKVM projects. Mostly Circum uses by the ZKVM projects. That's it. You just build a zero knowledge proof. Here's our topic is complete, and thanks for watching. See you in the next one.